Good evening. Good evening, everybody.
Good evening, madam. How are you?
All right. So today we'll start. Frank, I think you can share the screen so that we can start right away. My name is Dr. Subira Munishi, and I think you already have my bio. I work with the University of Dar es Salaam, and I'll be taking you through today and tomorrow. I also work closely with my research assistant, Engineer Frank Andersen. Will be with him also today and tomorrow. And so let's just begin. So we will take you today through two major sessions. So we'll introduce the satellite images that we are most likely to be using in estimating the water budget. But we'll also take you through the downloading process so that you'll be able to download it yourself, get to know different sites where you can do that. And then later, I think by tomorrow, be able to use the data and manipulate it in QGIS. We selected QGIS because it's easier for everybody. Even if you don't have license for ArcMap, we decided that we'll use QGIS, and then later tomorrow we'll be able to now estimate the water budget for the selected watershed. So we can start now. Basically, we know that in water resources management, key information that we need in establishing our water budgets for various river basin is number one, precipitation. Basically, we need several resources and sinks. We need to map this. And in either cases, we need precipitation. We need surface water. We need to estimate soil moisture and any storages. We need to also have an idea of the groundwater. We also need evapotranspiration. We need to understand the infiltration, that we can derive this from soil characteristics. We can derive it from a number of things. And then we also need runoff data. Most of the time, this is expected to be calculated or measured, but things like evapotranspiration, it's also very difficult to measure. In most cases, people estimate these parameters from water balance equation. Now, in this session, we want to obtain this from remote sensing observations. Why? Because we know that in most of the sub-Saharan Africa, we are dealing with engaged basins and very large river basins, and that we hardly have any observations on them. So we thought that we would like to take you through this next slide. Okay, so I have lighted here the major water budget components that we'll be estimating from remote sensing. And you can see it is possible. Precipitation data, especially, we will estimate this from combined TRM and GPM, basically image satellite data. Evapotranspiration, this time I will not have any snow cover because we are using a basin that is in Southern Africa region. So for evapotranspiration, we'll use Terra Aqua satellite. Though we can also use Landsat data to derive evapotranspiration, but there are several algorithms to do that, but that's a little bit more tedious. And if we want to know this, maybe we can have a separate discussion, maybe for 5 days, on how to run such, to write codes and run such algorithms and estimate ET from basically Landsat. But for this exercise, we will be using MODIS satellites because these are already ready-made. They are out there. And soil moisture, we'll use SMAP. Terrestrial water storage changes, we'll use GRACE satellites. And we also use JSON 2 and 3. Next. Okay, as I said, we will estimate evapotranspiration from the combined TRM and GPM. And the rest, as I've said, I've gone through this already, Frank. You can just keep this part. This one just gives us the detail of the sensors for each of the satellites that I was just mentioning. But I think Tanisha went through this earlier this week. Next. Okay, thank you. Okay, so if you look at the spatial resolution for the data that you'll be using, the combined TRM and GPM satellite images, we are dealing with data that is 0.21 degrees. We are looking at MODIS satellites for evapotranspiration, that is actually MODIS 16. This is actually the resolution of 500 meters, and terrestrial water storage, it's 1 degree. So we are actually looking at basically regional water budgets, because if you look at this, this is rather a little bit coarse. So for small watersheds, this kind of information may not work. For us, what we do with very small watersheds, we actually derive them ourselves. Like if you are interested, Landsat can give you 30, meter resolution and all that. So with that, it becomes a little bit tedious, but then you get more higher resolution data sets. But this is what we are going to use for our watershed today and tomorrow next. All right. We also thought that it will be important that we introduce another data sets that are also freely available on websites. These are the satellite images that are actually remote sensing products that are actually derived from land data assimilation systems, which is actually it's a water balance model. And it actually derives a lot of information that we can use for water budget. Now for this exercise, we'll be using GLDAS, Global Land Data Assimilation System, to be able to get the data that we need that is relevant for estimating different water budgets for these large river basins. Next slide. Okay, so the Global Land Data Assimilation System, GLDAS, this one actually is, as I said, is a water and energy balance model, and that uses remote sensing images, but the resolution is a quarter of a degree. So it's better, but it's still a little bit coarse for small. Still, I'll recommend this for regional estimations. And it covers almost every area of the Southern Africa. It's available every 3 hours daily, but we also have monthly products. Next slide. All right. Now, if you look at the inputs, what the model uses, it uses precipitation from what I've mentioned there. It also uses surface radiation and all that, but what is important, it actually gives us the soil moisture. It gives us evapotranspiration as output. It also gives us surface water, surface runoff. Now, things like soil moisture, evapotranspiration, most of the time we are not measuring this. So we take this GLDAS, it's actually a very useful model that will give us data, and actually this data is freely available on Giovanni. So you can easily look for this data, and today we'll take you through how to get hold of such data. Next slide. So this is just an example of, this is soil moisture. It covers everywhere, and Africa is well covered. Next, this is the soil moisture product. Okay, so today, as I said, what we'll learn in this exercise, we'll be able, for just today, we'll be able to download data from GLDAS. We'll also be able to download more this data for evapotranspiration estimation. We'll also be able to download the combined GPM and TRM precipitation data. We will also be able to download GRACE, and all this data we'll be using from tomorrow. We'll be using it tomorrow to now derive our own water balance, water budget for Limpopo Basin. Next slide, I think, Frank. Yeah. So as I said, I've already said this. This is a 4-part exercise. We'll download all that. For just today, we'll take you through where you can get this data on your own for your own basins. Next. So Frank, I think you can take them from here so that they can be able to download.
Okay, thank you, Dr. Subira. So these are the prerequisites of this exercise. So in order to derive a water budget for Limpopo River Basin, so you need to have a QGIS installed, and make sure you have a QGIS with long-term version, because those are the versions that have already removed all the bugs. But also, to download the data, you must have an account registered with NASA as data, but also you have to process Limpopo River Basin files, which we will share. There's no problem with that. Yeah, so for today, I will demonstrate how to access these data sets. So we will download precipitation data, evapotranspiration, runoff, and total water storage. But basically, we will have 2 scenarios for wet season and dry season. So for wet season, we will download data from December 2019 up to March 2020. And for dry season, we will download data from June to September 2020. We assume that at this period over the Limpopo River Basin is a dry season, and in the wet season, it covers months from December to March. Yeah, so I will share my screen, live screen, so that I can demonstrate how to access data. So we start by downloading a global data simulation system, specifically version 1. Okay, so hope everyone see my screen. So I start by demonstrating how to download global and surface data. So to download GLDAS data, basically this is a link. I will navigate to the link so that I can show live demonstration. So basically GLDAS data are available at the NASA repository known as GSDisk. This is a repository that is all kind of information that is produced through modeling, through a simulation of different models. So this is a landing page. You can choose to start the tour so that you can familiarize yourself with the platform. So the very first step to download this data, you must have an account registered with this data. So you can navigate over here. If you have not if you had not registered previous this NAS account, you can find a button for signing and sign up. So you can just sign up, but I will show maybe how you can sign up easier. So if you just open this platform for the first time, you can find a login link. So you can just click on the login link. Yeah, if you click that login link, you can find a sign up form. But I have an account, so if I click login link, the system redirect automatically and make it myself login. So if you are new and you have not an account with S data for NASA, you can just sign up. You can just fill up a form. It's very easy to fill the form, and you are ready to go. Just sign in and you will land over this page. So the first step to download GLDAS data. So you can just search over here. This is a platform. It hosted a number of data sets. So you can search a very specific data sets you want for your own use. So for our case, we want GLDAS. So I will search GLDAS. And basically, we need GLDAS that is produced using various of models. We use to call catchment land surface models. And basically, for this exercise, we will go for monthly scale data sets. And as Dr. Subira demonstrated, there's there's two main output for GLDAS, which is GLDAS version 2.0 and 2.1, but 2.0 it decommissioned in 2014, and our use case for today is 2020. So basically, we will not using GLDAS version 2.0 for that reason. We will use GLDAS version 2.1, which starts from 2000 present. You can find even data for today. So I will find GLDAS version 2.1, which has a monthly temporal scale. So basically, what we need is GLDAS. We simulated the over catchment land surface model, which is CLM. So I will find GLDAS CLSM, which is monthly temporal scale, and it must be version 2.1. So it is this one. As you can see, it is a GLDAS catchment land surface model, which is a monthly temporal scale, and it is the version 2.1 GLDAS. So I'll select this one and search. So here is the output. As you can see, this is the source data. It is produced using a simulation of models, which are catchment land surface models. It is a version 2.1. It is a time resolution is 1 month, and spatial resolution is 1 degree. And as you can see, its temporal resolution, it's begin from 2000 up to present. So there's a variety of approach to get this data set. It depends on your use case, but for our use case, we will use the Limpopo River Basin. So these data sets are too huge. So in order to decrease the size, so we have to subset the data from the global resolution to mask our study area so that we can just subset the data to our specific study area. So to subset the data, you can just click subset get data. But if you want to download the data with the global resolution, you can just click this link and download the data which has the global coverage. So I will subset the data. So just click the subset. So what is needed is to fill all this information. So the first information is download methods. So there's the first option that say get original files. So if we opt for this option, that means you will download the data with the global coverage. But if you want to subset, you can just select this option, get file subsets. So for this, it is needed to upload a shapefile maybe, or a bounding coordinates so that you can clip out the mask of any area you want. So this is our use case for today. I will clip and download the data only for the Limpopo River Basin. So I select that one, and then you have to select the temporal resolution you want. As I said, we will be having 2 scenarios for wet season and dry season. And wet season will start at December 2019 to March 2020. And for dry season, it started June 2020 to September 2020. So I will start by imported date, which is 2019, starting from December 2019 and up to September 2020. So this is our temporal scale for our exercise. We need the data from December 2019 to September 2020. So I've already defined my date range. So I'll go and define the mask area, the tide area that I want to subset the data. So the main option that is available is we have to input a bounding box coordinates for the Limpopo River Basin. So I will import the bounding coordinates, which is this one. This as a bounding coordinates. So before downloading data from GLDAS, you must create the bounding coordinate first so that you can download, you can mask the data. So this is a bounding coordinates, and as you can see, there is a green shade, and basically this is a location where Limpopo River Basin is at present. So the data that will be downloaded will be covering all this area. So make sure you check this box, use the define region, which this is a code define region to subset the data. So next step is to declare the variables that you want. GLDAS have a variety of products, several products. So you must select all the products that you need. So for our case, we will need data for evapotranspiration, precipitation, runoff, and terrestrial water storage. But there is a several option to go for it. You can download all of them at once, or you can download one by one. It depends on the level of computing you have. It depends also on the skills, because if you choose to download all of them at one file, then you must have a knowledge of writing scripts and codes, because the only extension that is currently available for downloading or assimilating multiple files over one file is you have to use the so-called netcdf file extension, of which you must have the knowledge of writing scripts to decode the netcdf files. So for our case, we will not go for that far. We will use a well-known GeoTIFF extensions to download. And when you use GeoTIFF, you have to download each variable one by one. So maybe I'll start by downloading evapotranspiration. So I will find evapotranspiration over here. It is here, evapotranspiration, which is in kilogram per meter square per second. So I select it. So there's an option for grid. So if you want to interpolate this data, you can go for this option, but I will not go for interpolation because I'm just using a small area. According to this data, it is a 1 degree resolution. So if we are using, maybe you are dealing with 2 river basins, let's say Limpopo and Zambezi, let's say you can go for interpolation just to balance those pixels. And make sure in the file format you select GeoTIFF, because we are downloading each variable at once. But if you will be downloading multiple products, but you assimilate them in one file, then you have to select netcdf file. But put in mind that you have to know how to script and to write Python script in order to decode those data sets. So after that, I will click get data. So these are the outputs. As you can see, I have evapotranspiration data from December 2019 up to September 2020. So I will be downloading this file one by one just by clicking the link. And as you can see, here is a pop-up window that asks me where to save this data. So I directed to save this data, but it is very good to save for later. So I'll save as evapotranspiration, but I have to specify this is a GLDAS product because we'll be downloading also MODIS evapotranspiration. So I'll be just saving for easy identification. Then I will go and download another one. So, okay, this is for January 2020. Yeah, so I'll save the same as January 2020. Then this is for February. Then I'll go for March. Then for April. Then for May, okay, this is for May, but our months are from December to March, basically, and June to September. So I will go to download data for June. Then for July, then for August, and last for September. So up to this point, I have been managed to download GLDAS data, specifically data for evapotranspiration for both seasons, that is wet season and dry season. So I'll go next to download data for another variable. So to return back, you can just click on this selected parameter just to define other parameters, and then click define parameters. So there is only one thing to change, which is variable. So I have already downloaded evapotranspiration data. So the next, maybe I can go and download precipitation data. So this is the option, total precipitation rate, which is in kilogram per meter square per second. So after selecting it, you can just click again, get data, and the data for precipitation will pop up. So the procedure very similar. You just click one by one. So start with this data for December 2019. So I'll be just clicking, but maybe I can create a new file to specify this is the data for precipitation. Then I can start labeling. This is a GLDAS precipitation, which is for 2019, December 2019. Then I'll go to data for January 2020. Then I'll go to February. Then to March. So up to this now, I've already downloaded precipitation data for wet season. So I go to download data for dry season, which is from June to September. So that is for June. I'm downloading this for July 2020. This is for August 2020. And last for September 2020. So I'll go again and change the variable. So another variable is terrestrial water storage. So I'll find terrestrial water storage. It is here, terrestrial water storage. It is in millimeter. So I'll select this option and click get data. And the procedure are very similar. Just click the link, rename the file, and you're good to go. So because I've already downloaded all this data, maybe I can go to demonstrate how to download other data sets. So the next slide is about downloading remote sensing products. So we will start by downloading precipitation data that is provided of image. So as Dr. Subira said, this data are the products for the GPM and the TRMM data that is a well-known precipitation data that is derived from satellite images. So we will use the same months for wet season. We download data from December 2019 to March 2020, and for dry season, we'll download data from June to September 2020. So this is a link. IMAGE datasets are provided or distributed by Jovan. So I will click this link. So also to download data over Jovan, you must have a NES account that is associated with S-Data products. So it's a very same account that was used to download GLDAS data, because all of these products are distributed under NASA's license, which is an open license. So this is a landing page for Jovan. So for the very first step, we have to make sure that you have logged in. So for IMAGE, as Dr. Subira demonstrated, they are provided under different temporal resolutions. There is 3 hours resolution, monthly resolution, weekly resolution. But for our case, we must maintain the consistency. As the GLDAS data we downloaded, we have the monthly temporal scale. So also for IMAGE, we will go for monthly temporal scale, but the IMAGE data have a very small difference, as you can see later. For GLDAS data, each month have a very specific data for that specific month. For example, the model that is used to produce GLDAS data always produce those data under the 3 hours temporal scale. So to get data for months, you have to accumulate those data with 3 hours temporal scale over months. But for Giovanni, our IMAGE precipitation data, the methodology is different. We have to accumulate those data over the respective months. So basically, for our case, we are dealing with wet season and dry season. So for wet season, let's say we have 4 months, which is December 2019 to March 2020. So we have to produce only one product for wet season by accumulating the data for December 2019, January, February, and March 2020. We have to accumulate to get only one file that will be representing precipitation for the wet season. So I will go and select the data I want. I want accumulated product. As I said, we have to accumulate all 4 months to be accumulated on one data set. So I will select map accumulated. So here is the date range. So we will start downloading data for wet season and then for dry season. So for wet season, the start date is 2019, which is December 2019. And the end date is 2020 of March. So I will select March. Then next, you have to select a regional bounding box or shape in order to subset the data, because this data also have a global coverage. So we have to clip out all data for Limpopo River Basin, and there are a variety of options. You can just draw a box on a map. You can upload a shapefile. You can add a bounding box coordinate, whatever the choice you think it is easier for you. But I will go for adding bounding box in order to maintain consistency. So this is a bounding box coordinate for Limpopo River Basin. So I'll go and add over here. So that is the bounding box. So the next step is we have to search the actual product that we need. So the product we need is IMAGE. So I will go and search IMAGE. And there is a variety of options for this IMAGE datasets. As you can see, there is IMAGE final dataset, there's the IMAGE version 6, there's IMAGE data that is 8, there's late version. So it depends on your use case. But just to explain a little bit, IMAGE is those datasets that are produced without, I can say, assimilation. For example, we have GPM, we have TRMM, so you can find maybe IMAGE early dataset can be produced only using GPM, and it can be like in TRMM, and so forth. So we want to use IMAG final. IMAG final is a data that is a final version that is already assimilated, already integrated, and ready to use. So we'll go for IMAG final and search. So there is a variety of product here. There is a data accumulated precipitation, there is a merged satellite gauge precipitation, and multi-satellite precipitation estimates. But for our case, we need a merged satellite gauge station because this product have a combination of multiple inputs, I can say, and it allow monthly temporal scale. So I'll go over this option. As you can see, the unit for each data, for example, for this data accumulated, it is in millimeter. This one has a variety of units you can opt to choose, and this one you can opt to choose as well. So I select merged satellite gauge precipitation estimate because it is most robust data set to use over Southern Africa because it has a multiple inputs and it's already calibrated for use. So basically, as a unit, I'll be interested with millimeter per month because as I demonstrated over GLDAS, I downloaded those data on a monthly temporal scale, but also this data will be in months temporal scale. So it is better to download in months unit just for easy conversion on the later use case when we are doing analysis and estimating water budget components. And you can see the source data for this is GPM. It has a temporal resolution of months. It has a 0.1 resolution, spatial resolution. And the begin date is 2020 to 2021. So it depends on your use case. If you have a temporal resolution later than 21 of September, then this data is not for you. So just click on this, you check on this box and click plot data. So it's generating results based on the input I provide. So this is a bounding box. I just feed it in on the system as I demonstrated earlier. So the very next step is very easier. Just on the download, click on this drop down. So I will download GeoTIFF because I expect to get only one product that is accumulated over 4 months, which as months is represented in wet season. So just click on this GeoTIFF data and I will save on another file. Maybe this is the IMAG data, IMAG precipitation data. And basically as IMAG data for wet season, I can declare for easy catch up. So I've managed to download the precipitation data for wet season. So I'll go again to download the precipitation data for dry season. Just I'll click this back to data selection just to define my parameters. So I'll just change my date. We are now downloading data for dry season. So dry season is from June 2020 up to September 2020. So this is the same product we use. So I just click plot data. So it's just generating the results according to the input you feed. Okay, looks like there's a pending request that is synchronizing. So you have to wait until it process all your generated inputs so that you can be able to download, but also it depends on the level of your internet connection. It can take a little more time if you have no good internet connection, but if you had not a robust computer system. So this is output for dry season. So I will download and save on this directory. So this is iMatch dataset, and basically for dry season. So up to now, I've managed to download iMatch dataset. So the next stage is to download MODIS evapotranspiration. So just a reminder, we have downloaded evapotranspiration as a product for GLDAS. So for this, we download evapotranspiration information that is derived directly from MODIS satellite images. So we will use the same temporal scale for wet season and dry season. But just for your information, MODIS evapotranspiration uses another kind of a data system we call it as GLDAS. So in order to understand information basic as a metadata for MODIS evapotranspiration data, or all kind of products that produced under MODIS, you have to understand how to count this GLDAS. So to download this data, just navigate to this link. It's provided under USGS, specifically on this LPDAC mission. So this is where you can download MODIS information. So the very first step is to sign in using the same NIS account. So after signing, just navigate to extract. You have to hide it where we have to extract those data. So there is a two main way to extract data. You can extract data in terms of area or in terms of points. It's depending on your use case. We will use the area because all the data set, let's say for GLDAS and the iMatch, we have used area. So I'll just go to area. So there's these three tabs. You can upload a request file, but these have to be in JSON. And you need, you need to know how to write the script to write this file. You can copy a previous request. So every request you generate, you will find it here. So if you want to re-download the data, you can go and choose a request. So these are my requests. So I will generate a new request just for demonstration. So if you want to generate new request, just click here. So we have to enter a name to identify a sample, because the way MODIS are downloaded, they will be sending a link to your email, which is associated with your NASA account, so that you can download those files. So you have to put a name for the product you want, so that you could identify easier. So the same, I will start downloading data for wet season and then for dry season. So I'll name my data as, let's say, MODIS, and this is for wet season. So the next step is to upload a study area, so that you can be able to mask or to clip out this global coverage data into your study area for interest. So this system only accepts shape files that is in the form of zip, and as you all if you are familiar with GIS, a shape file must contain all these 4 extensions, which are very important extension for shapefile. But also the easier way is you can just generate your shapefile in form of your JSON, and if you upload it here, you will find your study area over this map. So I will upload a shapefile for Limpopo River Basin, which I will share with you. It is already in GeoJSON. So if I upload, you can see it is appeared here. So all the data that will be downloading will be clipped out over this extent. So I select the start date. We start with downloading data for wet season. So I will start by importing a date for wet season, which is December 2019 up to March 2020. March 2020. Then we have to select the area to include in the sample. As for your information, MODIS have as that kind of products. So you have to specify which products we want. So for our case, we want evapotranspiration, but all the MODIS product have the, I can say, the product name, and all the product name start with mod 16. So for the mode 16, you can find the multiple product for modes you want. So for our case, we need product for evapotranspiration. So I'll go and find a data for evapotranspiration. But for your information, also modes have, I can say, two sensors, that is aqua and terra. So it is better to go for terra. So why terra? That is another reason. That is another, I can say, session. So we will go for terra modes evapotranspiration. That is 8-day resolution. I will say why 8 days. But as you can see, majority of modes data products have 500 meter of resolution, and its polo resolution is about 8 days. So I'll go and select Terra Modis evapotranspiration, which include the evapotranspiration and the latent heat. So it has a spatial resolution of 500 meter and temporal resolution of 8-day meter, and it is available from 2001 up to present. You can find all the data, but as you can see, this is evapotranspiration, but there is a data for evapotranspiration that is gap field. So if you select this data that is not gap field, you have to expect to find some of the missing pixels in the outputs. So we don't want to go and clean those missing value on ourselves. We want the data that is ready to use. So make sure as the data you download it is a net evapotranspiration that is already calculated, and it is a key gap field that all missing value have been filled. So I'll go for Terra Modis net evapotranspiration gap field, which is 5 meter and 8 days. So I'll go for this option. So if you click, there's multiple products that is coming from. There's a potential evapotranspiration, latent heat, evapotranspiration, but the only data I need is evapotranspiration, which is this one. So I will place on this add button, and you can see automatically it appears on this selected layer. So the data that will be downloaded will be only evapotranspiration, which is 5 meters. So only the data that appear on this selected layer tab are the ones that will be downloaded. So the next is to select output option. As long as we download only the one file, we have to select GeoTIFF. But if you download multiple files, you have to select netcdia. For example, if I may choose to download even potential evapotranspiration, there's 2 files. You cannot download GeoTIFF over here. You have to select netcdia file because it's a file extension that can accept multiple files over one file. So I select GeoTIFF, and this is a projection. I just select a geographical projection, and we will be doing the projection when conducting an analysis. Then next I click submit. So it is like I submit a request to the S data, and if I open my email that is registered with S data for NASA, I've just received an email of requesting for MODIS evapotranspiration data. So this is like an invoice, I can say, that you want this data. So they'll be processing in a matter of not more than 2 minutes, I can say, and they'll be sending a download link over the email. So it's a matter of waiting. But according to my experience, it has never taken more than 2 minutes to receive an email downloading link. So we can wait a bit for that link. Okay, as we're waiting for the link, maybe I can go and demonstrate how to download as a last product, which is a terrestrial water storage from GLDAS FO formation. It is also a NASA mission that is producing terrestrial water storage data with the same procedures GLDAS do. They just do a mosaic of output of different models to get this data. Unfortunately, this data for glacier formation have been decommissioned on 26th of September, I think is the last week. NASA advised that advertised that this mission is put on to an end, but all the data will be uploaded to the PODAC. This one will be uploaded to the PODAC web portal. So all the data will be downloaded from this dashboard, but for now it is not available online. So we'll be not downloading glacier for your terrestrial water storage, but we will be using terrestrial water storage from GLDAS just to estimate water budget. So that is for information. We will not downloading glacier formation because as far as this manual is concerned, it demonstrates how to download glacier formation has been available over the NASA drive. It was something like a Google Drive like this. It's like a list of images or a list of data set, I mean, all are listed over the drive, and you just find and fetch what you need and download. But this drive was put on end, has been decommissioned on 26th of September, and all the data will be available on a dashboard. So it's just a waiting time for NASA. If the large data is available, maybe we can arrange for other session and we can demonstrate on how you can download this graph for data. But I can say the alternative of this, we can use terrestrial water storage data from the GLDAS. Okay, we have not yet received the downloading link. We have to maybe wait a little bit because that is the only link that we can get to download our data.
Meanwhile, is everybody following? Are they at least trying to download by themselves? Are we together? Our participants, are they around?
Very much.
Yes.
Yeah.
Yeah, are we able to follow what
Yes,
Frank
we
is
are
taking?
following.
Yes,
All
we are
right.
following, but if we could get the links from the end of this session, it could be fine.
Okay. Yeah, you're getting the whole manual, which has the links as well in the presentation.
Yes,
Okay.
because the challenge we are facing is that
All right.
since from day one we didn't yet receive the material. It has been somehow complicated for us to do some exercise.
Are you not registered on the platform, on the e-learning platform?
We are facing the problem to do that, doctor.
What's the problem?
I saw some emails yesterday. Some of my colleagues, they were saying that they are facing the same problem.
Yeah, but for you just to say your colleagues, and I don't have emails from your colleagues, it's very difficult. I'm sure I enrolled you on the platform.
Yeah, if we log in the platform, it say that to enroll for the program, it must be by invitation.
No, once you are enrolled, you should be able to access the materials.
Okay, I've tried it yesterday, but I didn't get the material. So I will try it by the end of this section.
Okay.
And I will email you, I'll update you.
Yes, I think our downloading link is here. So this is our I have received the okay, I have received the downloading link. So this is the email and it looks like this. So here's a link that will be embedded with all the data product I just requested. So I've just opened the link. And the first option, it must redirect your login credentials to make sure that you have the necessary product so that they can reveal all the product to you. So these are the products that we have just requested. And as I said earlier, all Modi's products are in GLDAS, and that's why I can see there are many of them. So for example, if you try to read this data, you can find it is a mod 1682 GF. So this is just a product name. So it is evapotranspiration data. It is 500 meter of spatial resolution. And this is a Julian date. As you can see, it's a date of acquisition is 2019, and the Julian date is 3/29. So if you just search on Google Julian dates, you will find 3/29 correspond to which day, and you can just know how to count Julian dates. So as long as we just selected our time input from December 2019 to March 2020, all this data bounded on that period. They are from the first day of December of 2019 up to the 30th of March 2020. So I'll be just downloading all these products because they are all fall on the wet season for Limpopo River Basin. So just click on this box to select all the data sets. And then after that, there is an option here, download. Click on the drop down, and you can just download the files, or you can just save download list if you want to download them later. So I'll just download the file, and it will be just preparing file individually, and it will be popping out to request for you to select a directory to save those data. So this is the mode is a T. So I just saving this without naming because we have to understand first this Julian dates correspond to which day so that we can label the object. We can label this data comprehensive according to specific days of the months. So as far for now, I'll be just downloading the data, and we'll be labeling later if we already know the Julian dates of each image. So it's a matter of popping out up to all 34 products have been downloaded, and you can see it's preparing the 8 files out of 37. So you have to download all the files, and the processing will be done later because out of 34 files, we must identify each file corresponding to which months and just accumulate them so that we can get data for months wise, but also we can just run JS analysis, that is addition. We can add all the data to accumulate into one file, which will be representing data for wet season. So basically the same procedure will be used to download data for dry season. Maybe for time, I can cancel over here. But if I choose not to cancel, I'll be able to download all the 34 products. But you can also download individual files if you want. You can just select it and download the file. It will prepare, and a pop-up will appear for downloading, as you can see here. So up to now, I have downloaded the Maurice evapotranspiration data for wet season, and this as a metadata. If you want metadata, you can download over here. Yeah, so the next and final step is download Modis data for dry season. So to download for dry season is you have to return to this window and just change the dates. So for dry season, it is from 2020, June 2020 up to September 2020. So this is a temporal scale for dry season. And if I submit this request, you can find an email already received in my mailbox. This is a request, appears Modis wet season. Okay, I forgot to change as a product name. So it is very good to change the product name over here also, so that you can be able to differentiate this is a request. So this is a request. So the next step is we have to wait for a download link. So for the request for what is on it just took 4 minutes to arrive. So we have to wait again 4 minutes for a download link for more this data for dry season to arrive. And if the download link arrive, you just click the download link, it will get to here. So you just select all the data and download, and you're good to go. So the main issue that is basically not covered here is how to understand those Julian dates. But I think that we will be covering for tomorrow's session before starting the whole analysis, because before starting analysis, we have to perform some pre-processing. So in the processing stage, maybe I can show how to lead this Julian dates in order to understand, okay, this is the data for 2019, and you understand it is in December, but which week it is in, it is for, which date is it for, so that you can be able to understand the other time if you want to download data for months wise. So I will show how to lead Julian dates tomorrow, and also I will demonstrate how can you estimate water budget, do pre-processing, do analysis, and get the final product for water budget estimation. Yeah, I think I'm done. Over to you, Dr. Subira.
All right, thank you so much, Frank Andersen. I think this was a good one. So by now we should have been able now to download all our data sets. For those that came late, you will have make sure you register, and then you'll have all our materials so that you can follow on through, because by tomorrow we will not be downloading anymore. We'll just go quickly into processing the data sets. Do we have any queries and issues, questions?
Yes, good evening, ma'am. Can you hear me?
Yes, we can hear you.
Okay, thank you. With regards to registration, I've been trying to register, but I'm unable to. What can I do?
Maybe Primrose or Dr. Kujinga will help us with that.
Hello, come again, sorry. What's the question?
I've been getting a message. I did register, however, I don't have access to the course material. I keep getting the message saying you must be enrolled in a course.
Okay, we'll try and I will enroll everyone again. So all of you will get messages of enrollment. Once you are enrolled, you should be able to get onto the platform. Thank you. I will do that.
Thank you.
And did everyone fill today's register for recording purposes? All right. Okay, so Dr. Kujinga, we are done for today. Tomorrow it will be a little bit of tight because we need to do a lot.
Okay, so tomorrow, sorry, there was, because of time difference, I got a bit mixed up. What time are we starting tomorrow? Because when we are saying like 16 hours here, it's 17 hours in Dar es Salaam. What time, Dr. Subira?
No, for me it's all right, but maybe if others will not be able to handle that time, we can be flexible. But for me, it's still very fine. Let me hear from the participants if they have a problem with that time.